Okay, folks, we are beginning our last section of this chapter, and it's regarding the substitution rule. It's a way for us to take integrals. In order to introduce this, instead of starting with the notes, which is right here, I'm going to bring you through a problem that you're familiar with. And what I'm going to do is I'm going to take the derivative of this function. And you recall that if you take the derivative of x cubed plus 1 raised to the 10th power, you use the chain rule. And that tells you identify the inside, which is x cubed plus 1, and you identify the outside, which is u to the 10th. The derivative of u to the 10th is 10u to the 9th, and the derivative of x cubed plus 1 is 3x squared. So as you multiply these together, notice that you get 30, and then not only 30, but x squared, and then it's x cubed plus 1 raised to the 9th power. That is, in fact, the derivative. Well, what I want to do is I want to take this and I want to find the antiderivative. So finding the antiderivative of this is very important because it's going to lead us back to this guy right here. We know that you take the derivative of this to get that. So now I'm going to try to go backwards, okay? I'm going to try to go backwards. And here's the process. We start by identifying what's on the inside. So I'll set it up as the integral of 30 x squared times x cubed plus 1 raised to the 9th dx. That's what we're trying to determine, the antiderivative. And the way I start this problem is identify what's on the inside. And the inside thing is x cubed plus 1. I'm going to call that u. And then we know that there's a derivative that sits here, and we will call that du. What is the derivative of x cubed plus 1? The derivative of x cubed plus 1 is 3x squared dx. So I know that this is new, but I want you to look at what you have here. What we want to do is we want to change these variables. Instead of having any x's, we want them to have u's in them. And if you look, we can take this guy and replace it with u. And we can almost replace this guy with u. As you look, it says 30x squared. This is 3x squared. I need a 30 so I can substitute it there. And if I just multiply by 10, notice I can replace the 30x squared and the dx with a 10 du. So our integral becomes, instead of 30x squared dx, I have 10 du. And instead of x cubed plus 1, I have u to the 9th. So now, what is the antiderivative of 10u to the 9th? Well, it's 10u to the 10th over 10 plus a constant. Those cancel, and I get u to the 10th plus c. Remember, what was u? U is x cubed plus 1. And that's your antiderivative, which is exactly what we started with. Now, it would only be normal if you're a little bit confused after seeing that through. So just hang on. This is a few day process, but we're going to do our best to help you get started on this, okay? As you glance at this piece right here, I want to know the antiderivative of this. And that's tough because I got something multiplied by something here. I can't do our normal process. I'm going to do substitution. And I say that u is equal to 4 plus x cubed. Okay? Now I'm going to say the derivative of u, the derivative of this piece right here, the derivative of 4 is 0, but the derivative of x cubed is 3x squared dx. Well, I can replace that and that with du. and I can replace that with u. So what is the integral of u to the fourth du? U to the fifth over 5 plus a constant. U is 4 plus x cubed. So 4 plus x cubed raised to the fifth power over 5 plus a constant. That's the antiderivative. That should have felt a little bit better. Here, u is equal to 4x squared minus 3. The derivative of 4x squared minus 3 is 8x dx. I don't have an 8. I have a 7. So I'm going to divide both sides by 8 to get 1 over 8 du is equal to x dx. I don't have an x dx. I have a 7x dx. So I'll multiply both sides by 7. Now I can replace the 7x dx with 7/8 du. I can replace the 4x squared minus 3 with u. I have u raised to the third. What is the antiderivative of this? It would be 7u to the fourth divided by 32 plus a constant. Substitute back in for u. We have 7 times 4x squared minus 3 over 32 plus a constant. I'm going to do another problem that's not in your notes, one that might help you out a little bit. I'm going to find the antiderivative of 3 sine of 2x dx. Notice that it's just not sine of x. It's got a 2. So I say that u is equal to 2x. That means that du is equal to 2 dx. I don't have a 2 dx. I have a 3 dx. So I'm going to divide by 2 to get 1/2 du is equal to dx. And then I'll multiply by 3. I can now replace the 3 dx with 3/2 du. 3 over 2 du. What's left? The sign is still there. We haven't replaced sine, but we have replaced dx, or 2x. We replaced it with u. What's the antiderivative of sine? The antiderivative of sine is negative cosine of u. And what is u? U is 2x. If you ever wonder if you did it correctly, just take the derivative of that, and you should come up with that. Got a little bit of time left. Let's try one that looks like it's a little bit more difficult. This looks really difficult because you have square roots all over the place. What I'm going to do is I'm going to say that u is equal to the square root of x. If you haven't figured out by now, u is often, not all the time, but it's often the thing that sits on the inside. And you can see this piece right here, say on the inside of cosine. Don't worry about that guy on the bottom. The derivative is equal to, what's the derivative of the square root of x? You should say 1 over 2 roots of x dx. Now, look at what I came up with. In my derivative, I came up with that thing on the bottom. It's sitting right there. But I have a 1 over 2. I want a negative 2 over 3. So I'm going to multiply by 2 to get 2 du is equal to 1 over the root of x dx. Now I just have 1 over the root of x. And it looks like I want a negative 2/3. So I'll multiply by negative 2/3 to get negative 4 over 3 du is equal to negative 2 over 3 roots of x dx. So I can replace this and this and this with negative 4/3 du. Notice I wrote the negative 4/3 out front. You don't have to write it on the inside every time like that. You could just slip it outside too if you want. It's just a multiplier. What's left over? I have cosine, but not of the root of x. I have cosine of u, because the root of x is what goes in for u, and u goes in for the root of x. Now we just need the antiderivative of cosine. The antiderivative of cosine is sine. So we have negative 4/3 sine of u. U is the root of x, plus a constant. That's my antiderivative. We're going to do one more. Do this one last one here on the front. I wrote the wrong problem. It should be the integral of 4 plus tangent of x cubed secant squared of x dx. This looks like a super complicated problem. It's not too bad. Identify u as 4 plus the tangent of x. The derivative of 4 plus tangent of x, the derivative of 4 is 0. The derivative of tangent of x is secant squared of x dx. Notice that I have a secant squared of x dx sitting right there. So I can replace this with just du. So we have the integral du. What goes in place of this? U. Sorry guys, we got this phone situation. It's u cubed. I'm going to take the antiderivative of u cubed. I get u to the 4th over 4 plus a constant. And what do I put in for u? I put 4 plus tangent of x. That's the antiderivative. The substitution rule is like the chain rule in reverse. It's the most powerful rule you have for finding antiderivatives. I want you to know this is not a one-day deal. I want to prime your brain so that when we do it in class, hopefully it won't look as foreign. If you're feeling a little confused right now, it's okay. We have some other problems that we're going to need to see through when we get to class time. And then we need to get to some, well, let's just say more challenging problems as well, ones that are slightly more difficult. Okay? And so that's just a nice little introduction. And hopefully that can get you started. If it doesn't get you started, don't worry. We will work on it together. But just be ready to keep trying, and trust me, you'll figure it out and you'll do quite well with it. But I would say that this would be the majority of your test, is finding antiderivatives in whatever way we need to. So, hope you have a great day. Reach out if you need help, folks. We'll talk to you soon.